Hi, back in the workshop again this morning. What are we going to do today? The next job is to deal with this. This is the last chunk of rusty metal from Model Engineer's laser. And this is for the inside connecting rod. This is quite a bit more complicated because it has to clamp around the crank on the leading axle. I've tried to work out I worked out how this happened on Morrisshire, and I've tried to simplify it to an extent for working on the model, but to try and keep it as close as possible to what it should be. So first thing is going to be to clean this thing up. Linisher, I guess, bench linisher is the solution as we did with the other ones. Once we've got a reasonably clean bit of metal, then we can start separating the two parts and figuring out what to do next. Right, so clean this thing up on the belt linisher and with the Dremel to get rid of all the laser marks. It's come up a lot easier than the other rods did. So yeah, next job is to cut these two pieces apart and start to mark this up so that I can plug that back onto there. Now we have some tactical challenges how we're going to work on this. I think the first job will be to square this thing up, cut these so that they're clean and square both ways, and then face that. And once we've got there, then we can start to mark up how we need to cut this. Again, we're going to have to be holding it that way up and cutting that way, I guess, in order to get the slot to fit here. So I think we're going to have a lot of alignment challenges here. I mean, to cut this one in the vise means clamping on those two sides, and means you don't have a reference in that plane really, because that's a sloping surface. I think it's necessary to mark this up and mark the center line, and as we did with the other rods, use the center line and visually line that up on the vise, because there's no physical option there to do that. So lay this over the drawing and see how close we are. Pretty close. Those curves should match exactly. They don't quite here due to laser cutting and a bit of fettling. There's quite a lot of fettling there. I think I might work that curve a little bit better because it's got a little bit of a lump in it. Yeah, you can just see there. Dremel time again. Well, I've done some work on this conrod. I've made these two pieces fit together. I like that. That was done on the mill, and it was done by essentially matching the two parts up as much as measuring. Basically, I kept taking small cuts and then checking them for fit, and they are pretty close fit just now. There we go. So the next challenge we have is fixing these bits together. So I've marked up centers for drilling. Drilling in this way isn't practical. We haven't got anything that's going to get past here. So what I'm going to have to do is set this up that way up. I've drilled down from the top into this bit, and once that's done, use that to mark out the faces on this, put that in the vise and drill that downwards and tap it. You could ask quite why I'm doing all this, because this part is buried deep inside the engine, and once it's in and the boiler is on, it's never going to be seen again. But I just like the idea of doing it correctly. I mean, one concern, or the major concern I have about this part is we have a very small area there to put a thread in, which is going to have to hold this together. Need to go over to the mill now and figure out how we're going to mount that thing vertically in order to be able to drill these 2 points. This is a starting point. The rod is as far down as it can go. The mill head is as high as it can go. All we need to do now is try and make sure this is dead plumb vertical. Okay, so we should now be set square over the edge of the piece. All that has worked out correctly. We need to go in half the depth. That's 2185, so that's 0.109. Well, that is wobbling like crazy for no reason that I can see. Okay. This is our number 35 6BA clearance drill. Just a touch of MWF on that. Let's see how this goes. And we have that as 0 for our X at the moment. So how far do we want to go over there? If we go 11915, that should place us directly above that. So I've gone to incremental scale so I don't lose my original X, and what I want to do is to go back 0.089. That looks correct. Don't like how that's wobbling around. Okay. Touch the old MWF. Let's see how this goes. Gone through. Right. Okay, back to the bench. So we now have 2 holes through there. We need to translate those onto this piece very accurately. I feel like there's a gunge in there somewhere. Let's clean this out. The question is, can I get the pin vise down the side of the hole? Just. Two perfect marks. So what we're going to do now is put this back in the vise, and we'll set up the vertical on that line. That will make sure that the holes are concentric and vertically correct. Now, This one is going to be very, very close to the edge, if not even break through there. If it starts to break through, the drill's going to try to move that way. So I need to be doing very carefully with that one. That one's got more solid ground to land in, so I'm less bothered about that. So what I'm doing is exactly the same process I used to line this up in the vise before. Okay, so we're lining these up visually because the sense of this doesn't seem to work. I don't know, I can't get everything in lined up. Let's see what's going on. I'll just have to trust the markings I've made and go with that. So. And we've got the gauge on the side here, so zero that there, approximately 0.125 inch. Okay, so this comes out, center drill goes back in. Right, while we're still set up, let's set up for tapping. Okay, that's good. Okay, so those holes are tapped. I've got 3 full threads in there. Okay, let's take it out, try and bolt it together and see how it feels. So, I think I've called this series by the right name, How Not to Build a Locomotive. The challenge from the outset was this part here. I was always a bit concerned about the lack of thread depth. This is actually scaled exactly from Murrayshire, and I think we've reached a position where it's not directly scalable part to make it functional. The conclusion is that, well, I took a couple of goes at this. The conclusion basically is that that part doesn't work. So what I'm going to do now is to take this lump of mild steel, square it up, and make another part here. Not quite the same shape. I'm going to leave it square to the ends just now until I get the threads in. And once I've got the threads in, we'll see about shaping it, but I suspect we're going to take a different curve to it. We can't be 100% to scale, even at this quite large scale, because laws of physics and materials that we work with don't always scale all the time. So the first thing to do with this is to cut a section off it and then square the bar on the mill. Once I've got it squared, I'll cut it to dimensions. Quite a lot to go away. I don't really want to mill all that off, so once I've got it square, I'll probably mark this up and take bandsaw to it to cut it down into something more reasonable. Let's get on with it. Bit of a burr on that side. Let's have a go at getting rid of that. It's going to end up getting cut away anyway on the bandsaw in a second. So let's just clean this up and go from there. Okay, so now with bandsaw cut it very square. I'm going to get it back in the vise on parallels and hack away until we get down to the flat, and then we'll measure it to get finished depth. Okay, we now are flat. What we've got now is 4, 8, 5. 10th now. Be about right. So let's get this out and mark it up as to what we want to do with it. So let's see where we are in principle. So we've got that line, that line. What we want to do is to take the rod, offer it up, and start marking out where we need to make this hole. Okay, doing by the numbers, that's what we should have. X is now at 0, which is on that line, so it should be minus 1665 on that line. Z is currently zeroed on top of the part. We need to go down 0.3255. So let's give it a go. What I'm going to do is take about 10th thou cut and see how that fits with the part we're trying to match. So it's a touch narrow, but actually not. I think that's right. Okay, so let's start chunking away between those numbers and see where we end up. So take 15,000 just now. Is spot on next to Y, and just get down to Z. to go. So 19, it should be 255. Just okay, that's it for numbers. So that is cut right down to the numbers we expected. Feels quite good. Let's take it out and have a close look. And test fit. Well, I'm currently looking through my bits of broken hardened metal to find something that's a good bit for that hole. They're pretty close. Maybe what I do is I try and work with this one. So what I want to do is to grind it down so that it's a good fit in there and put a point on it. Okay, let's see if I can make a mark or not. Okay, let's see to depth. So I've got 6 BA taps and my preferred tap wrench, which is, it's got 6 BA plug tap in it, which we don't want yet. Taper tap. Another thing we don't want to happen is broken taps in here. Get rid of the bar. And try 6 BA through it, make sure it feels comfortable and goes all the way in. That feels good. So the Y should be the same, which we have zeroed. The first thing to do will be to use a center drill. Looks spot on. 3/32 tapping drill. Right, that felt a bit strange. I felt a little bit grabby from time to time, which is not ideal. Right, moment of truth. Will this now go together? Well, the holes line up. The main challenge is that even with 7BA heads, there's not enough clearance to put a box spanner on. Now if we look at the photograph, you see what we have on the real thing is extended nuts that bring the hex out beyond there, so it's easy to get a spanner on. We might be doing that. It's tight. That's tight. Success! So the next problems we have are drilling holes, big holes. This one needs to be for this, so as per the drawing, the diameter of the actual hole is 0.777. Now I guess what we're going to do with that is we're going to drill it out to 1/2 inch and use the boring head to get it out to the final dimensions. We may have to solder this together and turn it into that bit. I put a dimension on this because the centre of that hole is here. What happens when I drill this? I don't know until it's done. Happy with that morning's work because we've achieved something that we were struggling with. But it would be nice to round these off and finish that oil box to dimension. But before I do any of that nicety, I want to get this hole drilled in case it screws up. I have to make this again. Okay, so that's the holes drilled. I've drilled this one out to 5/8 at the moment, and that one is 1/4 inch, which is what it needs to be. Now the next challenge is fitting it to our jig. So before, what happened was that was centered on the big hole and that was centered on the little hole. Because this one is a slightly different length, if we center this one on the little hole, we miss the big hole by a bit. I'm just wondering whether we should make some different spaces for this, or just try using a 1/2 inch spacer and see how that fixes on. So before I put this on the mill, I'm going to just try these things on the bench and see how we go. Right, so that is bolted down hard with the 1/2 inch spacer in, and nothing seems to be wanting to go anywhere. Let's tighten this one down as far as we can get it. So, next task is to start carving out this lot. Challenge again is going to be how we actually do that bit at the end. That's a much shallower taper out. I've done the setup a bit differently this time. First off, I've set the thing up in the back slot rather than the, you can't see that, the back slot here rather than the middle slot. That was so that I have more room at the ends. I'm going to bash my knuckles off the toolbox as I wind the X out. I've set up the X's by eye as best I can, and I think I need to take about 85 thou off of each of these sides. So what I'm going to do is I'm going to start cutting some fairly light cuts, probably 15 thou at a time, and let's see how we go. Lots more noisy milling. Well, I would say there's about 20 thou still to go there, but where's the guessing stick? It says 25.5 thou. Take 2 cuts, 10 each way, I think. So. So it's 90 thou off that side. So what we're going to do now is flip the rod over that a ways, because it's symmetrical, and do the same again, 90 thou off the other side. Well, actually, before we do that, let's take this boss down. Let me figure out dimensions for that. So we learned our lesson last time about climb milling the boss. That's where you get into trouble. So we're going to go that a ways. We just need to put a couple of clamps on this, just to give us whatever rigidity we can get. Okay, works both ways. 0.77 thou off. Okay, that should be correct. Now, time to take this off and flip it round the other way. Right, we're all set up now to cut the other side of the rod. There's 90 thou worth of packing in behind it. We're going to take a 90 thou cut again and then just see where we are on dimension. Okay, the final cut on this side of 30 thou, so 2 50 thou passes, one conventional and the other climb to get a good finish on this, and then we're going to have to tackle these. I got the cat out at home and had a look at what this should be. In the drawing it's a spline, which means multiple different radii across it. However, a 5.2 radius gave a circle that was a reasonably good fit for it, and I think in terms of how this is going to go, that is what I will try and do. What I've done is I've drawn the angle on the drawing between the striking point of this and the end of the arc. And I've used this contraption to try and set that against the centre line that I've got drawn, and visually taking that line with shadows showing it nicely. Quite accurate. Okay, so if we lock that off, what we're going to do is we're going to transfer that angle over to the mill and figure a way to fix the jig to this angle, and hopefully we can make a straight cut by doing that. Okay, I tried doing it by the numbers and that didn't quite work, so what I have done is I adjusted it by touching off the cutter here and here to get the point where I've got a good reasonable surface, which is going to have to get curved on the either by draw filing or on the linisher. So what I can do now is I can invert the rod, leave everything else exactly as it is, and I should be able to achieve the same cut in, on the other side, on that inside face, without having to change any of the settings or any of the DRO settings. That's it, bolted back down. You understand the rod looks like it's bowing a bit, but that shouldn't really affect this end very much. Okay, what I'm going to do is put a clamp on there. finish this end. Where I should be. Go up to 60, take it cut along and see what we've got. Not exactly symmetrical, but as good as we're going to get. So let's take this off and have a look at it. Okay, so that's the finished rod as it is. Definitely in need of some linishing. Lots of machining marks that side. Lots of machining marks there. That's it. Yeah, that needs a good rubbing down. Okay, and then we've got to figure out how we're going to finish this. At the moment, it's functionally correct. It needs an oil hole in the top. You could probably do with this trimming down and potentially a bit of a curve putting on there. It's not going to be matching the original drawing by quite a long way, but as we discovered, trying to do things to the drawing to scale with that just didn't work. Okay, linishing time. So that's the job cleaned up on the linisher. Pretty much all the burrs are gone. That's not quite perfect yet. I'll give this another run. It's a bit better. Still slight signs of machining marks there. I'm going to take the Dremel and the little drum to the corners that I haven't managed to get into and see how that works out. So let's just give that a quick run over with Scotch-Brite glue, of which I got many off eBay the other day. Right, I think black is the coarsest. I'll try the mini Dremel for that. Well, best finished rod's going to be the one that's hidden. So I've decided against doing flutes in this. The original one does have flutes down either side, but it's never going to be seen. And I think there's a risk, as is probably one of the most stressed components on the engine, of taking too much metal out of this. I'm pretty happy with this. Straightness is pretty good. So what are we doing with this thing? Let's put some blue on this and we'll have a little look-see. So here's some genuine old-fashioned equipment to do this with. So if I just set this here and follow that round, Takes us right back to there. I think I need to go further out than that because this is the problem down this corner. Let's set this to the side edge of the block. Do the same again. That looks more reasonable. Okay, we'll take the mess out of this on the bandsaw and then see where we are. Okay, roughly to shape. A bit more to be taken off there, that needs to be cut flat. So I've now rounded that off on the linisher to the line, so it's not a machined surface, but I think that is a good solution for getting things rounded neatly enough. I mean, the proportions aren't quite right because it's much bulkier than the prototype, but in the scale we need the mass, I think. So operation still to do. This, both ends need boring out and bushing. I have the bushing material here for that end. I had hoped to get onto bushing during this video, but unfortunately not. The bronze for the coupling rods just turned up today. Well, it's actually gunmetal rather than bronze because by all accounts it's going to be easier to machine. I've never played with this before. The bronze I've got is phos bronze and it's really hard and really difficult to work with. So let's hope that's going to be easier. We can see the difference, colour difference. I mean, it looks very brassy. Once we get it on the lathe, then we'll see how this cuts and see if it's better. So let's keep that for another day. So today I'm declaring this rod finished apart from the bushing and the oil box. Please consider subscribing and liking the video, and if you don't like it or if there's any things you have to suggest about improving these videos, please do leave comments. Thank you for watching and I look forward to seeing you next time. Bye.